Here we'll look at Chemistry 1, Paper 1, wherever it is, separating mixtures. So, what we got is a little bit, the idea is like in chemistry we mix stuff together all the time, in life and everything else. You can put tea in boiling water, you put milk in there and everything else. You can put salt and sugar in water and it dissolves and vanishes and so on. So we're mixing stuff together all the time. If you drink Ribena of an evening, if you put Ribena in water, that's a mixture. But in chemistry, we're interested in how we would separate those back out again. So how would we, in that example, get the Ribena and water separate again? So also in ink colours, how do we find out what colours are in the ink? For example, if you add yellow and blue together, you get green. So if you've got a green ink, it's possible to separate them out and get yellow and blue back again. So what we're going to do in chemistry is to find out different methods of separating mixtures out again. So, as I said before, if we mix salt into water or sugar, it dissolves, it vanishes, we can't see it anymore, but it doesn't mean that it's not there. And we can actually get the salt and the sugar back through something called evaporation, where the water comes off, leaving behind the salt. Now, distillation, you might have heard of, but maybe not, is used to separate two liquids or more. Now, if you have ink and water together, you have inky water, obviously it's probably black. Now, but if we want to have the ink in one glass and water in another, so essentially separate the water out from the ink, first of all, we have to heat it. So the water boils at a lower temperature than ink. So the water evaporates off first, becomes a gas before the ink does. So the ink stays as a liquid, the water becomes a gas and evaporates off. And if we can catch that steam, that gas, we can collect the water and the ink is left behind. Now this is the equipment that we use. So on the left, you've got your flask with your mixture of liquids in there. So in this one, it's probably just impure water, but pretend it's ink and water. We heat it with a Bunsen burner. The vapors come off, the gas comes off. So obviously the water boils at a lower temperature than the ink. So the water boils off first, goes up. There's a thermometer to check the temperature because we don't want it to go too high so the ink evaporates off as well. And then we've got a cooling tube or a condenser. You'll notice that the cold water goes in at the bottom and comes out at the top. The gases get passed through there, they condense, so they turn back into a liquid and they drip out at the end. Now, what drips out at the end is the water and the ink is left behind. And that's pretty much the method there. It's quite simple. You just heat it, trap the steam, condense it back into a liquid, and then trap it in another beaker. Now here is chromatography. Now that separates inks into their original colours. So for example, if we have a green dot, it will separate out into blue and yellow. If we have a brown dot, it will have many colours in there, like below. So here, you put the ink dot on a bit of paper, you dip it into water or a solvent of some sort, and that slowly moves up the paper and it separates out the inks into their different parts. There's a maths thing for that one as well, but you get the equation in the paper. And that is a very basic one for separating mixtures.